All right, this is the second part of the solutions to yesterday's FRQs. I made a separate video for these two because they're most FRQ-ish, like the most true FRQ like you'd see. So I wanted to make a separate video where I go into a little bit more detail about how grading would work. All right, so in question 13, the computer printout below gives regression output for predicting crime rate in crimes per 1,000 from the number of casino employees in 1,000s. So the first reason I picked this is usually you will not be actually asked to calculate a regression equation. It'll either be using these formulas to make a regression equation, these first three formulas, or you'll be given a computer printout. So here's a computer printout. And for now, if it's involving regression, this is the only thing I care about. This first column, and then really how to get the regression equation. So for A, give the equation of the least squares regression line for predicting crime rate from a number. I can literally just fill in the blanks. Well, here is the Y-intercept, and the Y-intercept's the constant, so this number is going to go up here. And then the slope says coefficient and number, right? The X is number of employees. That's going to go over here. So my regression equation will be rate hat. I should really put a hat on it because it is a prediction. So predicted rate equals negative 0.398 plus, because this is positive. A common mistake is you'll put a plus even if it was negative, but plus because that's positive, 0.11832 X, or here it's number. When I run out of space, I'll just put num for number. So there's my regression equation. B, give the value of R, the correlation coefficient. So R, I have R squared. So to get R, I'm just going to take the square root of that. So R is going to be the square root of 0.974. Whatever that is, you can check with my solutions. And then next, give the predicted crime rate for 20,000 casino employees. So 20,000, obviously that's what I want to put in for number. But I don't want to put 20,000 because it's already in thousands. So I'm going to cross out these three zeros. It told me in thousands. So I'm just going to put 20 in. So this 20, I will plug in for that number and calculate and find an answer there. So I showed this question again, usually in an FRQ or a multiple choice. A lot of times you're given a computer printout. So that's how you read a computer printout. I'm going to jump to question 20. Question 20 will involve a little bit with interpreting. So let's go to 20. A study of right-handed people found that the regression equation for predicting left-handed strength measured in kilograms from right-hand strength is left-hand strength equals 7.1 plus 0.35 right-hand strength. What is the predicted left-hand strength for a right-handed person whose right-hand strength is 12 kilograms? So this is pretty easy. I'm just going to take that 12, I'm going to plug it in for X, or plug it in for right-hand strength, and type that in the calculator. I think I get, let me check, I get 11.3 kilograms there. You can check my work on my answer sheet, but I'm really concerned with the second part. Interpret the intercept and the slope of the regression line in context of the problem. So let's talk about slope. So if I go back to my problem, here's my intercept, sorry, my intercept's first. So my intercept is 7.1, that's the Y-intercept. So in general, what that means is that's the value of Y when X is 0. But I need to remember context. So 7.1, that's the value of the left-hand strength when the right-hand strength is 0. So in general, a Y-intercept is the value of Y when X is 0. I need to apply context. So what is my Y? What is my X? So what we say here is 7.1 kilograms. A person with 0, let me start over. A person with 0 kilograms of right-hand strength is expected or is predicted to have a left-handed strength of 7.1. So I'll say that one more time. A person with 0 kilograms of right hand strength, again when X is 0, is expected to have 7.1 kilograms of left hand strength. Now, if you have trouble remembering these interpretations, look at my little cheat sheet. You can use this for now. Here's my regression line. Here it says my interpretations. B is the Y-intercept, the value of the predicted Y. So here, 7.1 kilograms of left-hand strength when right-hand strength is 0 kilograms. So that'd be using my fill in the blanks. But as long as you realize Y-intercept is the value of X or the value of Y when X is 0, just apply that context. What's the problem about? Let me go to the next thing is interpret the slope. So the slope here is 0.35. And remember, slope is change in Y over change in X. So change in Y over change in X. Let's just go ahead and put this over 1. So change in Y over change in X, or change in left-hand strength over change 1 unit change in right-hand strength. So what we would say here, for each additional kilogram of right-hand strength, I expect or I predict the left-hand strength to increase because this is positive, by 0.35 kilograms. And go back to my little cheat sheet that you have access to. Here for slope, change in predicted Y. So here I expect the left-hand strength to increase by 0.35 kilograms per 1 kilogram change in right-hand strength. That's how this works. And the order, you can say the change in X first or change in Y first, but as long as you're putting context into these problems, you should get full credit regardless of the order. So again, as you answer that FRQ that you're assigned today, check back to that little cheat sheet I give you when you're making your predictions for slope, Y-intercept, or even if they ask you to predict R or R squared down here, predicting R squared, little math libs for you. Interpreting residuals, how you interpret residuals. So make sure you do not forget about this little helpful cheat sheet when you're working on your FRQ today.